Hey everybody, today we're going to be figuring out how to write a quadratic equation from a table. So let's go ahead and take a look. Normally, when we figure out patterns in the table, we do our delta y over delta x's. So I'm going to go through that process really quick by figuring out what my change of x's are and what my changes of y are. So let's go ahead and draw on some arrows. Obviously, my x's, each time I move to the right, I am going up by 1, right? So from -4 to -3, I added 1, -3 to -2, I added 1, keep going. You're counting by ones, obviously. Let's see what my y's are doing, okay? So this went down by 7, then down by 5, down by 3, down by 1. Then I'm starting to go up by 1, up by 3, up by 5, and up by 7. This doesn't seem to follow a consistent pattern, but you can see there is a pattern on the numbers on either side of my center value. So what I'm seeing here is this center value is my vertex. And I know this is not absolute value because if it was absolute value, the numbers from here and here would be the same because I'm going up by 1 here. So I am going to go, I think this is quadratic. And if I think it's quadratic, I'm going to start at the middle number where it was a mirror image on either side, right? So mirror image over here, mirror image over here. And I'm going to see if I can figure out the pattern and construct the table that made this quadratic. So I'm going to restart here with my y values. And I'm going to say, I am starting at 0, 0, and I am working outward from it because 0, 0 is my vertex. So if I go to 1 on either side, I added 1 to each side. Now from 0, if I go to 4 on each side, I added 4 on each side, right? I'm going to keep going. Going to my 9s. Obviously from 0, I added 9 to each side. And then I'm going to my 16s. So I added 16 to each side. So what I'm going to do is I'm going to reconstruct this table. This is going to be my pattern about the vertex table. So my x and my x squared, let's see what's happening. So I'm going to start with my first one, which is right here. I moved left or right 1 square, and my y values went up by 1 square. So I moved left or right 1 square, and my y values went up by 1 square. Let's go, and just to be clear, that is going to be, sorry, I'm trying to highlight, not cross that out. Let's try that again. That is going to go with the yellow bit that I highlighted. Let's try the next one. If I go left or right 2 squares, right? So I went 2 squares from the center. I went up 4 squares. So if I went left or right 2 squares from the center, I went up 4 squares. And that is what I highlighted in green there. Let's keep going. If I go left or right 3 squares, I'm going up 9 squares. So left and right 3 squares, up 9 squares. That's what I highlighted in blue there. And let's try one more time. I went left and right 4 squares, up 16 squares. So left or right 4 squares from the center, up 16 squares from the center. We know that this is a perfect pattern about the vertex table. That if we go left or right 1, up 1, all we did was square the value on the left side of our table. Left and right 2, up 4, right? This is a standard pattern about the vertex table. 2 squared is 4. Left and right 3, up 9, right? 3 squared is 9, and left and right 4, up 16, right? 4 squared is 16. So I know that my coefficient here has to be 1 because this value only went up by x squared. If it went up by 2x squared or 4x squared or 3x squared, we would have a different coefficient. But because our pattern is 1, 4, 9, 16, that means we just squared the value, meaning my vertex starts at 0, 0, which is what I have circled here, and it goes up 1, 4, 9, and 16 as I go out from the center. So I'm going to write this equation. Always starts with y equals. I can write down 1 if I want to, but 1's invisible, so I don't need to. I know I'm going to have an x. I don't need to add anything because my vertex is at 0, 0. So I can just square it, and I don't need to add a 0 to the back. This is just going to be y equals x squared. This is the most basic form of a quadratic that exists. Now let's try something a little bit different. Let's look at this table. So because we're doing quadratics here, I'm not going to show you that change in y. We're just going to go out from the center. We'll figure out where our center is, and we'll see what the pattern is. So here we are going up by 1 every single time, up by 1. And then if we want to just see our pattern, we can see that on either side of this 4, the numbers match, right? The 5 and 5 go together, the 8 and 8 go together, and the 13 and 13 go together. So I'm going to use that to construct my pattern about the vertex table. So my vertex is here at 1, 4. If I go left or right 1 square from the center, I'm going up 1 square. If I go left or right 2 squares from the center, so 2 squares, from 4 to 8 is plus 4. If I go left or right 3 squares from the center, from 4 to 13 is up 9. So 2, 4, and 3, 9. So I know this is a standard x and x squared pattern about the vertex table. So again, my coefficient is 1. But the difference here on the last one, remember our center was 0, 0. On this one, our center is 1, 4, meaning our vertex on this one is going to be at 1, 4. So let's try to construct this equation. We're going to start with y equals. We don't need to write down 1 because 1's our coefficient. It doesn't do anything. We are going to write down x and then the opposite of the x value of our vertex. So we have a positive 1. The opposite would be negative 1. Then we go ahead and square it. And then the y value of our vertex is positive 4. You throw that on the back. So x value, opposite, just your plain old y value. That is going to be how you write your quadratic equation in vertex form from the table. All right, let's try another. So I see this is my vertex immediately, right? Because these are all going up by 1. I know that already. These are all going up by 1. When I go 1 away from the center, I'm going up by 2. So we have something slightly different. I'm going left and right 1 from the center, up by 2. And I want you to give yourself some space right here, okay? So just give yourself some space. Trust me, I'll show you why. If I go left or right 2 from the center, I am going up by 8. So left or right 2 from the center, up by 8. If I go left or right 3 from the center, I'm going up by 18. If I go left or right 4 from the center, I'm going up 32. So this isn't following our standard 1, 4, 9, 16 pattern like we normally have in the pattern about the vertex. So what I'm going to do is I'm going to leave some space here, and I'm going to set up my regular x and x squared table. Well, I know if I go left and right 1, I'm going up 1, left and right 2, up 4, left and right 3, up 9, left and right 4, up 16. But my numbers don't match that. I'm going to try to figure out what number I multiplied the middle column by to get the pattern that I had from my table. It's usually easiest to go with the 1 square and see what you go up by. Obviously, I went up by 2, meaning I multiplied this 1 by 2 to get there. Well, I multiplied this 4 by 2 to get to 8, and this 9 by 2 to get to 18, and this 16 by 2 to get to 32. So I know I multiplied my middle column by 2. That means my coefficient here is 2. Remember, my vertex is at 0, 0, so I can write that down. You don't even need to include that in the equation because if there is no vertex, it's obviously going to be right in the middle at 0, 0. So let's try to construct this equation. We're going to start with y equals our coefficient, which we determined from the pattern around the vertex was 2, and this is an x squared. We do not need to write plus or minus 0 because it starts in the center if there's nothing adding or subtracting to the x value. All right, let's do one more here. So I can see my vertex is here at 3, 3. This is my vertex. I know that because the numbers match on either side of it. If I go left or right 1 square, okay, so left or right 1 square, I am going to be adding 3 squares to the center, right? So to get to 6, I had to add 3. So this is going to be a positive 3. If I go left or right 2 squares, I'm going from 3 to 15, which is adding 12. And if I go left or right 3 squares, I am adding 27 to my vertex, right? 3 plus 27 will give me 30. Yep. So add 27 to each side. So I know I'm not following my typical pattern of x and x squared because that goes 1, 4, 9. Let's see if I can figure out what I'm multiplying my regular pattern about the vertex table by to find my coefficient. Just as a reminder, it's easiest to start with the left and right 1 to see what you go up. Obviously, I multiplied 1 by 3 to get there, 4 by 3 to get 12, and 9 by 3 to get 27. So my coefficient is 3. Now, my vertex is at 3, 3, and my coefficient is 3. So let's go ahead and write it out. We'll have y equals my coefficient, which I got from the pattern, right, as 3. And then I'm going to do x minus the x value from my vertex, which was 3. So I'm going to go minus 3 squared and then plus my y value. So plus 3. So a lot of 3's there in our last problem. But this is how you write quadratic equations from a table. It is complicated to work it out, so you'll just have to work on practicing it. And if you're permitted a calculator, my suggestion is to take these equations, plug them into the calculator, and just make sure